Welcome back, everyone, for part two of this session. In part one, to summarize, we focused on one question and one question only. What is MLOps? And what are its key components? Why does it matter? And how do we go about it? Right? I hope we have had enough discussion on it. We have argued that our definition is slightly different from mainstream. We are saying MLOps is to do it right. Not just to do it, but to do it right. And that is what we'll focus on in this course. Now, getting back to the course, what we would like to do is take you through a demo. And I'll walk you through the demo. We will show you this this is almost the hello world of machine learning. It's a California house pricing, a very appropriate thing because most of you, those of you who are renting, would rather the house prices went down, and those of you who are owning would rather the house prices went up. And so this exercise is based on real data that was done actually 3 decades ago on California. Things haven't changed much. The prices have just perhaps quadrupled, but more or less the overall statistics remains the same. It is the hello world of machine learning. Whenever you do a regression, you encounter this California housing data set. If you have not done it, do not worry. It's a very simple exercise. We'll give you the code. Assume that with the code, you can make progress. Remember, our goal is MLOps, not to do an excellent exercise of predicting house prices. That is done. The model is there. So towards that, we will use 4 frameworks. Jenkins, 4 pipelines today. Jenkins, Airflow, Flight, and Qflow. Why is that important, guys? We want to show you working scenes. But the homework for you is what we did for one of the data. Let's say that we did Jenkins and Flight for California dataset. Your job is to do the other 2 datasets, for example, to do breast cancer dataset, to do the clustering dataset, or something like that. You need to do 1 lab with that on your own. So in the beginning, we are making it easy. It's a little bit like mirroring what we have done, repeating. It's a very regurgitative exercise, or to oversimplify it, it's a monkey see, monkey do kind of a thing. But you'll get practice in the sort of the ways and means of MLOps. So with that, we will go to the IP address. So Chandra, the IP address for Jenkins is?
Should I put it on the Zoom? Where should I? Because I put it on your Discord earlier.
Yeah, so then it is all right. I will take it up from there. Yes, I have it.
Okay.
No, you have to give me the explicit IP address.
Oh, you're not able to go to Grace Hopper, is it? Okay, 1 second.
No. If this is on the Windows machine, I will.
Yeah, I'll give it to you. 1 second.
68.1.221, I believe. It was 221.
1 second, I'm giving it to you.
All right. And
you got it already?
Given this. Yeah. Okay, there we go. So guys, Jenkins is something. Is there how many of you are not familiar with Jenkins? I know one person, some of you are not. Jenkins is the oldest of the pipelines of workflow framework. So you want to think of it as just a get things done. You give it some code, you say run it every hour or based on this condition or something like that. You just schedule the job. Right? It's a thing in its very simplified version. It's a job schedule with a user interface, and you see how your job ran. Now, if you don't know it, do not worry, because we'll take you through the process of installing Jenkins and becoming familiar with it. Right? That's one of the things will happen on Wednesday, I suppose now. So In this exercise, we will take this breast cancer data. So a little bit of a background on what is this breast cancer data. It is, the more formal name is Wisconsin Diagnostic Breast Cancer Data. It is from the 90s, and it represents actually one of the surprising milestones and the uses of machine learning. When people have are suspected of breast cancer, women are, and it's quite a scourge. Most women are scared of this breast cancer, very much as men are scared of prostate cancer after a certain age. So there are multiple ways. You take an X-ray. If in the X-ray any anomaly shows up, regular mammogram, any anomaly shows up, then you are sent for a core biopsy. You used to be sent for a core biopsy, which was invasive. It would leave a scar. You would go in, cut out, take some tissue, and then put it under the microscope and look at it. It remains sort of a gold standard still, core biopsy, but generally there is an easier way that people have done. It is called fine needle aspiration. What it means is go with a thin needle and just aspirate or extract a tiny bit of the tissue. The fine needle aspiration is usually the next thing these days diagnosticians do, physicians do, if they suspect cancer. Right? In different countries, the norms are different. In the US, I suppose they may go straight to core biopsy. But in India and in much of Britain and Europe, they do fine needle aspiration first. When you do fine needle aspiration, you look under the microscope and you see whether the tissue has cancer. So one of the questions that was asked is, can you train a machine learning algorithm to detect cancer, to be able to tell whether a tumor, if you see something on a X-ray, on a mammogram, by definition, it's a tumor. Tumor is any kind of anomalous tissue. The question is it benign and harmless, or is it malignant? Is it cancer? The word people use is malignant. Is it malignant? So one of the early things people did is they did feature extraction on the tissue. They would look at the circumference, the area, the this and that, and tell whether this is malignant. And why would you be able to tell, for example, from the surface area of a cell in the tissue? The reason is cancer, by definition, is fast replicating cell. That's what cancer is. When a cell, typically all cells divide. So once a cell reaches maturity, it has a propensity to divide into two. Right? That's how cell growth takes place. But in cancer, what happens is a cell doesn't reach maturity. Even when it is still tiny, it replicates. And then that cell again replicates and replicates. So you end up with a cluster of relatively small cells. That's a hallmark of cancer. Now, therefore, it is a problem that people thought in machine learning community that you could certainly create a machine learning algorithm to, first of all, do some way of feature extraction and then do a diagnosis. A surprising result was, which in those days was very surprising because machine learning algorithms were not as evolved. Today we have computer vision. So we would handle this problem very differently. We would just use a visual transformer. Right? But in those days, you did feature extraction and then you did a model. Here, we use, I believe, a random forest, which used to exist in the 1990s, and a support vector machine, support vector classifier, two algorithms to see which one does best, to build a model. So what are the stages of the model? You get data. When you get data, data may not be proper. It may have missing values, it may have errors, etc. So you do pre-processing of the data. You ingest the data. Your data may come as a CSV, but you don't want to deal with CSVs. Typically, we want to keep data properly, guard the data in proper data stores, right? Then you want to pre-process the data and do feature extraction. Then you want to split the data into test and train, training and test splits. Typically, you do three-way split, a train, validation, and test set, but simply put, a train and test. Once you have the data split into train and test, then you go through the process of model building. And that will show up when you look at it, look at this whole thing from a pipeline view. So what happens is, if you look at this particular run, which was done 18 hours ago, breast cancer ingest will ingest the data, then you do some pre-processing, and what they are is just cleaning it up, rationalizing it, and so forth, and normalizing the data, standardizing the data. Thereafter, you go through the train test split, and finally, once you have that, you want to feed it through a cluster of algorithms, in this case, just two, random forest and support vector classifier. And then, of course, out of that should come metrics that you store. So this is a pipeline. And each of these pipelines in Jenkins, it's very simple. Like if you look at this a pipeline and how it is done, you can say, this is, let's go into this breast. And if you look at the configuration of this, typically what you do at the heart of it is this line, which I will blow up so it's readable, maybe not so, but it's readable. As you notice, Jenkins just says, give us the command, the shell command. We'll run it. What does it say? Run this Python on a Python script called ingest main.py. Therefore, you can assume that you have this breast cancer data ingestion pipeline, right? There is something that will ingest. Well, it turns out that we are not going to give you this particular code because it's a solution to your first homework. Your job is to take the breast cancer code and be able to reproduce what I'm showing you. It's straightforward. As you can see, nothing is needed. You just have to give this command, and after that, this machine becomes ready to, for each stage, you have a job. And if you look at this dashboard, you will notice that all of these jobs have some command associated. There is also a dependency, which you saw in the pipeline. And so if you execute through all of them, you are executing an ML pipeline, machine learning ops pipeline, isn't it? At the end of it, what are the things you will get? You will get pre-processed clean data. You will get a split, test train split that you can save. You will get a trained model, and you will get some model metrics at the end of it. Right? And finally, you can, the one thing that we haven't shown you here is taking this model to full production. That's part of it. We'll come to it. Albert, go ahead.
So are you downloading the data set from the datasets online?
Yeah, we'll give you all the instructions.
Okay.
Albert, in fact, I'll hand over shortly to Chandra. We'll start with the instructions. So this is one of them. The second of them is the same thing. We will look at another port. The same thing with, let's try our luck with this. Welcome to Flight. When you come here, Flight will give a project some name. So we will sort of look at it. Now, one of the things you notice that is nice about Flight is it's very contemporary. So you notice that it says that for every project, you should have at least 3 environments: development, staging, and production. It's highly customizable, but we'll live at it. Let's go into the development. What you notice is that it has been through a run, and nothing very complicated. Suppose I go into this task, or you can see more about it, and you can launch this workflow, and it will start running, right? And there is a very visual way to look at this also, which Chandra will shortly take you through. But I'll just give you a quick.
Click on that version. Click on that version. You will see the graph.
In the version itself. Huh? Okay.
You click. Yeah.
There we go. So I'll show that, but you will see a much more detailed explanation shortly. Now, this graph, ignore all the lines coming out of start, because every task, of course, has a start, right? And it is a bit of a nuisance in Flight that the way it makes the diagram is, it sort of has start going to each of the order. But look at this. Ingest leads to pre-processing of the pre-processing task, which leads to train, validate, test, split task. And then you feed it into 3 algorithms. So this one, by the way, is random forest. This you'll get the complete solution, right? So you will see this solution, and you can use the solution to now in flight do your breast cancer, to do your clustering, and so on and so forth. That would be a homework. Linear regression, decision tree, and random forest. You have to create the pipelines for it. So this is your flight. Then, likewise for airflow, we will go to, let me go to 8001, 8081 is the airflow thing. And again, admin and airflow seems to have a very interesting password for reasons that they enforce strong security, I suppose. We will go in with this. So once you go in here, once again, you will notice that we have been up to quite a bit of mischief, and you will see lots of...
No, actually a lot of those default, just go to the active one. Yeah.
There is the active one. So this is it. So when you go in here, you get this. And maybe Chandra, at this moment, I'll hand it over to you. You want to walk people through this?
Yeah, I mean, just go to the graph. I mean, because we are going to do a detailed code walkthrough later, but for now you can show the graph alone. And very similar, whatever Asif already showed with both Flight and Jenkins, we have a similar pipeline. It is, the point here is that we are using Airflow to create this pipeline here, to create the same kind of dependency of exactly the same jobs.
Right. Except that in this case, the data set that you are using is the breast cancer data set.
No, Airbnb. We used Airbnb. I mean, just for a variety, we used a different data set here, but conceptually it is the same. We are taking data, ingesting, pre-processing it. I mean, it will have its own columns because Airbnb has its set of features, and both what we want to predict, they're different. But idea-wise, it is similar to California house pricing.
Good. Yes, and you'll get all this code. By the way, all of this code is a starter code that you will have access to if you don't already.
Right now, in the whatever we have shared in the course portal is only the California housing, because we would like the students to try out based on, I mean, we have the notes, we have the database setup instructions, but we are giving the solution for California housing, and using that, they can try to do that for Airbnb or breast cancer.
But have you given the sources of the data also to get it?
We will give it. It is. We'll give
so let's post it to the course portal and the spot.
Yeah.
So that. All right, guys. So at this particular moment, you may be realizing that there are so many ways that you can do the same thing, and there are multiple pipelines. See, this is a question that keeps coming up. Should I use Jenkins? Should I use Airflow? Should I use Flight? Or should I use Kubeflow? And the answer that I always give is, A, based on what you're familiar with, go with that. If you're a small team or if you're a one-man team, remember, MLOps is not going to create a business differentiator for you, most likely. You need to focus on your key differentiator, your secret sauce, right? So you want to give minimum energy to MLOps. As your organization grows, move up the complexity scale. Start using things like MLflow, Flight, Kubeflow, and so forth. Large organizations cannot do without Kubeflow or Flight and things like that. So now I will give the same thing for, so for Kubeflow, you're saying, Chandra, that we need to
I can share my screen because I have it open, because there is a little bit of a setup involved. I mean, it is basically you need to SSH. So shall I share?
Yes, please do. Please take over now.
Asif, this looks very neat. This looks the best, in my opinion, at least for what you showed. So
except that the Python is not up to date. It's nice. It's nice. Yeah.
Everyone seeing my screen?
Yeah, we are seeing
Oops. One second. I just had a Strange. Just when I'm clicking on it, I had a, okay, I think it is still visible. Now I had a power shutdown. Strange. I had a power shutdown just as it was.
Okay.
Is that a Windows?
So Chandra, should I take over or you want to continue?
Just as I was, I had, okay, now it's coming up. Okay, I had a power shutdown and my laptop went off. Now it has come back. Are you able to see my screen?
Yes.
Yes.
Okay.
Yes.
So this is the Kubeflow pipeline, which is doing it in a using Kubeflow pipelines. We are creating the same flow for the California housing, and the only difference here is that we need to go through localhost. I mean, unlike the other cases where Asif showed directly you are going to the IP address, we have to do an extra step here, which is why I decided I will do it on my system. So basically, we need to do a login to the machine on which the Kubeflow pipeline is running. We need to map the port on which it is running down to our local host, and then we have to view it. That is the only catch.
No, this is temporary, guys. At this particular moment, right?
Yeah.
This one will post away so that
Yeah.
you can watch.
Can you please come again? What did you do to make it work?
Basically, to map a port on any other machine on which you SSH to your machine, you do an SSH minus L. So this ends up mapping the port on the target machine into your local host on the same port, so that you can view the Kubeflow pipeline on localhost now instead of having to go to the IP address.
Okay. Do you proxy it also on the Kubernetes side, or like it's just
right now? I'm just doing this port forwarding.
Okay, for now.
Yeah. No, Gopal, we are doing it because on our network we are having some glitch.
Okay, got it.
It is not necessary, but yeah.
So Asif, can we run all these pipelines on one machine? They don't.
Can you? Yeah. So Albert has a question here. Can we
Yeah.
run all these pipelines on one machine? So the answer to that is yes and no. You can run Airflow, you can run Jenkins. Make sure you run on different ports, and you can run now Flight and Kubernetes. Flight and Kubeflow, they are both Kubernetes based, and therein comes the complication. You can't run them at the same time because you can have one Kubernetes cluster running. Generally, it's not a good idea to have multiple Kubernetes cluster, even locally running on your machine. So bring one up, you play with it, then bring the other up. That's one limitation. But yes, you can bring them all up on your machine, and the machine that you have, Albert, certainly you can. Okay. So
yeah, I mean, right now in the machine that we were running, we couldn't bring both of them up because both of them are standalone clusters. There was a conflict whenever we were trying to bring both of them up. Maybe, I think if it is a cluster in the true sense of a cluster where you have remote machines and you're creating cluster, then of course there's no issue.
Guys, speaking of this clustered part, see, the reality is for clustering, for orchestration, we live in a container world now. Almost all deployments are in containers which are orchestrated through Kubernetes. Kubernetes is the big gorilla here. Now, Kubernetes is pointless if you run it on a single machine. In reality, you run it on a Kubernetes cluster. For example, if you go to GCP, you have the Google Kubernetes engine, GK. They have simplified it so that you don't have to really learn Kubernetes very well. You just need to know the kubectl commands. Right? Nevertheless, in this course, you will work with local clusters. Setting up a Kubernetes cluster is a rabbit hole. Unless you are really smart at it, I would not advise you to go, because what will happen is you'll spend the whole course just trying to set up a Kubernetes cluster. Right? It's not an easy thing. Now, At some point later on in the course, we may give you access, we will perhaps give you access to a three-server Kubernetes cluster here to run some of your distributed compute jobs, but that will come later. Now, both Flight and Kubeflow has a massive mind share at this moment, though it is beginning to show its age. It's a vast ecosystem, lots and lots of features, lots of things. Right? Flight is the young kid on the block. Both are very good. Likewise, Airflow and Jenkins, these are the most mature pipelining frameworks. My recommendation would be very strongly not to learn just one or two. Learn all of them. The whole point of this course is we will help you with our code, with the help that you'll give you to quickly learn all of them. These things individually, if you try to learn, you'll struggle, but we are here to help you learn them. So do please learn all the pipelines. Broadly speaking, all the technologies that you teach, we have made the examples quite easy so that the learning is easy. Follow along and learn.
And the advantages, at least for these three, Flight, Kubeflow, and Airflow, the code to create these pipelines looks almost identical. Of course, Jenkins, we don't have a Pythonic way to create it. We have to go and manually create. But otherwise, this workflow creation is very similar in the three. Only the setup part is different. Okay, I can stop sharing.
Chandra, I would like us to now go through the exercise of setting up the Python development. That is the first day. Should I take them through, or would you like to?
I mean, it is there in the. It is there in this.
Yeah, that's
basically right. Yeah.
Let me take them through.
So should I stop?
Yeah, you can stop, and I'm taking it through. So, guys, this one is going to be, where is that thing? Yes. If you're looking at my screen, it's a very simple setup, guys. First things first, make sure that Anaconda is a generally good idea to have Anaconda installed on your machine. Many people just use Visual Studio and they get away with it, but I would strongly recommend independently having Anaconda installed. What does Anaconda installation mean? Let's go and check it out. And how complicated is it to install? Well, you have to go to anaconda.org. The web page looks like this. This is their symbol, I suppose, is that scary snake. Then you click the download, and as simple as that. Once you click the download, you can skip registrations if you want, and just it will auto detect what your operating system usually is, and you can just click the download. And then you download it. Once you download it, so let me pretend to download. So as you notice, it is downloading here. And once it downloads, all you have to do is run it. I won't run it because on this machine, it's already installed. That's all you need to do. You just need to install the Anaconda software. Now, what we will do is, today we want to make sure that you at least understand the instructions. On Wednesday, we will do this follow along exercise, and we'll go through it step by step. Once Anaconda is installed, Anaconda is what is called a Python distribution. What does that mean? Python is a language, but the power of the language comes from the many, many rich libraries that people have created using Python. So when you do work in Python, 90% of the time, you're not using the core language. You're actually using the libraries. These distributions are a judicious combination of those libraries, necessary libraries, as well as a simple way to download any library and install it. That's what they give you. They give you a well-managed Python environment. And so that is what Anaconda gives you. Now, Python is at version 3.12. we don't encourage you to use 3.12. We would request that you stay with 3.11 for some part of this course. Now, why would we go with the older version? Because some of these libraries, they have not caught up with the latest. For example, Ray framework, which is a big part of this course. Almost half the course is Ray, does not yet work officially with 3.12. It works with 3.11. So stick with 3.11. Now, Python, it is very easy to start doing development and have all sorts of library conflict. This is the Python version of the DLL hell that some of you may remember. Right? So there is a way out of it, fortunately. You create isolation. It's sort of you containerize each Python project. And the way you containerize each Python project is you create something called a virtual environment. A virtual environment is like a guarded, it's like a walled garden. Within that walled garden, whatever you do, you're unaffected by the world outside. And towards that end, once you have Anaconda installed on the Unix shell, you'll have access to a command called Conda. And the first thing that you do is you create a virtual environment. Let's say that your virtual environment is called ripe apricots. So you will give the command Conda create -n. -n stands for name, or you could give -- name, but -n will do. And you give at this, instead of my_n, replace it with, let's say, ripe apricot, or whatever your name is, right? You can give it, but give it a name that you can remember. Don't give it a, so this is not a password that you give it a very cryptic name, right? Give it a memorable name, and then always a best practice to be explicit about the Python version. Right? Don't let Conda pick a default Python version. Always be explicit. Do that. So when you do that, a Python environment is created, but you haven't entered it in the shell. To enter that environment and start working in that walled garden, that is the mental picture you should have. It's a walled garden. And there is a gate to it. To enter that gates of the walled garden, you need to give another mantra, which is this: Conda activate, and the name of your whatever name you gave to it. When you do that, you enter that. Then what you need to do is, you have downloaded this this zip file, tar zip file, and you must have inflated it in some directory. Right? Go enter that directory. So that step is missing here. You need to enter that particular directory wherever you installed your file, this zip file. I mean, you sort of inflated it, right? Unzipped it. There, enter that directory. And once you enter that directory, do a pip install -e dot. There is a dot that you shouldn't miss. You see this dot here, right? I'll increase the font size a little bit more and see where my mouse is. There's a dot. Pip install -e dot. So I'll give you a little bit of an explanation of what it is doing. Dot in Unix stands for this directory. Right? It's a simple way of saying this directory is dot. -e is saying be dynamic. In other words, if I make changes to the code, pick it up. Right? You're signifying to the installer that code will change, and therefore this library will evolve. Right? That is what it does. It creates a library out of your code base. In Python, you speak in terms of modules and libraries. So your Python library, what we have given you is a project that builds a library. That library is now in development mode. Then we strongly encourage you to use Visual Studio Code, actually VS Code, not Visual Studio. There's a typo here. It should be Visual Studio Code. So what Visual Studio Code is the de facto, and most of you have been using it. I am saying this for those of you who are new to it, to development. Very easy. It is the de facto king of the hill in the world of programming for a reason. It really makes learning how to develop Very, very easy. So just go download it for your operating system and install it. Once you have installed, you will see, do you see that there are this brick things? It stands for extensions or plugins. Then tomorrow we'll take you through the process, if you have not gone through it, of installing and you can sort of follow along. Do not be worried if this is all new to you, because you will follow along and we'll make sure you get there. You need to install Python. Visual Studio is a general purpose programming sort of a studio. It's a tool. You can do C programming, C++ programming, JavaScript programming, Java programming, Python programming, Rust programming. Pick your language, you can do it. So, and they don't, out of the box, come with support for every language. They instead let you download the necessary extra extensions for a language. So we will install the Python extension. Once you do that, you must have noticed that when you inflated your tarzip file that you downloaded, it became a directory call, a folder call, MLOps week 1. All you do in Visual Studio is you will go into that and you will open that folder. Now, on Wednesday, we will take you through it, like literally step by step, if this is on YouTube. And then you will also change your interpreter to this environment, whatever name of the environment, so that you sort of make Visual Studio aware of that environment and use the Python from that. And that is it, you're ready to go. Now, those of you who have been doing Python, for example, coming from my previous courses, to you, this may look obvious, but for those of you who are new to Python, rest assured that we'll systematically take you through this. And though it looks intimidating, it's actually quite easy. Nowadays, 8-year-olds go through all of these steps, and they happily, in an hour or two, they pick it up. So if 8-year-olds can learn, surely you can rest assured that it will take you less than 10 minutes to pick it up. And it's really a pleasure. Python is one of the most pleasurable languages to code in because of its utter simplicity. Learning curve is a matter of minutes or an hour. You can become really good at Python in 2 days. And Visual Studio makes it even easier. VS Code, Visual Studio Code makes it even easier. Now, a bit of typo here. We are using Visual Studio Code, not Visual Studio. Visual Studio is a close cousin of Visual Studio Code, but we are using Visual Studio Code. We'll fix that. And one of the beautiful things that this gives you is, suppose you have, you set up the environment here on your desktop, let us say. You are anywhere else in the world. You can actually take a laptop and connect using Visual Studio Code to your home machine, to your remote home machine, and continue working on it as though nothing has changed. And your work will remain on your home machine, but to you remotely in your travel, it will appear as though you are working on your laptop. You'll be working on your laptop, but work will be happening on your desktop. It's really powerful. Now, there is also the VSCode.dev. There is even a web front end to Visual Studio Code. You don't need to do anything. You just need to visit the website, VSCode.dev, and from there, you can connect to your remote machine, right? And you can have a pretty native experience of working with Python. So the combination of Python and VS Code, especially with the web version coming along, has really made this a very productive, easy to ramp on, and no hassle environment to do programming. This is something that you should go through. But then in the next lab, you will also go through, in order to do this lab, setting up a database. And here it's very simple. We'll take you through the steps. Again, do not worry. We'll use a simple database. One of the simplest databases called MySQL. These days, people prefer a variant, a clone of MySQL called MariaDB. It is basically MySQL. as you can see, all the words are MySQL root, MySQL password, and so forth. We'll take you through the process of setting it up. Very simple. You create a. If you already have a MariaDB or MySQL, then you just need to run the script. It will create the tables needed for the first project. These are just simple tables. Now let's look at the tables. Why are you creating these tables? One of them is MLOps data store, California housing. So you will store the California housing dataset in this table. It's always a good idea not to store things in CSVs, but to import it from CSVs into it. And then you will create another database called feature store. This is for raw data. This is a raw data database. Now we'll pretend as though we are creating another database, but in reality, just another schema called feature store. In that feature store, again, we'll have a very simple table, which is identical to the first table, more or less, except that data here has been processed. Null values have been taken care of, missing values have been taken care of, data has been normalized, scaled, so on and so forth. And irrelevant variables have been thrown out, features have been thrown out. And it also has things for experiment number and so on and so forth for the feature, which experiment it is used. And then you do the data, you will do the split of the data, right? Training, first of all, features versus target variable. And then you will also do a split based on whether it is meant for training. This data is training data or it is validation or test data, right? Because once you split, you need to remember it. Split type is there. That's what this table is. And finally, when you train your model and you do model level metrics and test metrics, you need a place to store your model metrics. So in the very simplest form, we'll store it in just another schema called this thing, model metrics. Right? So this is it, 4 simple tables. This is how you will store your data, right? And for those of you who are familiar with databases, relational databases, this may look easy. If you're not, trust me, it is easier than it looks. Right? This looks like bizarre SQL code, but actually there's nothing to it. If you look at it carefully, these are just common. Go ahead, Albert.
So once you pip install that particular code base, then you can see all these.
Yes.
Okay.
It will take you through.
And is it the standard way of building? If you get a data set, these are the tables and this is the structure of the database?
No, see, we wanted to simplify it for you. We created the schema, but for breast cancer, we'll expect you to maybe pull a bit more weight.
Okay, but the concept is kind of the same. Like
you
build a thing,
you follow the
fields and yes.
Exactly. In the same way,
we have the columns there also. There are 2 other guides below, right? In the left hand side, breast cancer, and we do have the table names specified for them also.
So this is for Airbnb. As you can see, this is exactly the same structure. One for storing the features, one for storing the split, the test train split, and the features versus target variable split. Right. And one for model metrics. Likewise for breast cancer. Right? You notice that by now it's beginning to look rather repetitive, isn't it? It's very repetitive. So this is it. And now the pipelines that you will create, there's a little bit of a summary. You will see documented here.
Ask a quick question before you move on.
Yes.
What is the advantage of using databases versus just storing this information in CSV files?
Versioning. See, if
CSV files.
When you store things in CSV, think about it this way. You'll have to maintain a lot of CSV files, and any changes to the CSV files, you wouldn't really be able to concurrently change it. Let's say somebody wants to add 5 more rows to your data. Then only one person can edit the CSV file. Yeah. Databases were invented so that multiple people could work on the same data. That was one reason. The other thing is databases, of course, give you acid properties. Yeah? That all operations are atomic, either they happen or they don't happen. You have concurrent access, there's integrity of the data, durability of the data, means you should just assume that databases are rock solid. If you throw your data in, it's like putting your gold in Fort Knox, right? It's not going to walk away or evaporate. It's going to stay there. Right? CSV files, your file system crashes, you're done for. Databases are usually guarded by somebody called a database admin, whose entire reason for existence is to make sure that nothing ever happens to the database. And in case the machine burns away, you can immediately restore the database on another machine. And usually they maintain failovers. Right? So databases are very robust data stores compared to CSV file. So it's always a good practice. See, the reason we are doing it is in this simple case, you can say, hey, I could have saved the features and the metrics also in file. For simple situation, yes, but as you deal with lots and lots of models and highly complex data and data at scale, you can't do it. See, the reality is at industrial enterprise scale, the data that you train your model with is ginormous. You read off things like Big Table, right? Or Snowflake, massive data stores. From there, you load it, and then you do all the sharding, and you'll go through it when you do the Ray framework, the sharding and piping, and you do distributed compute of models. Yeah? We are going to go there. That's the end journey. At this moment, crawl, walk, run. So we are still in the crawling stage. That's that. Yeah? So now we comes to pipelines. Jenkins is very straightforward, doesn't need a pipeline. But here it is, Airflow. This is here just to show that
actually Jenkins is there. It is there inside the detailed. We have a section on it, but there is not much code involved there. It is more visual. That's why I didn't put it here.
Okay, good. Yeah, no, thanks for that, Chandra. So clarification. So this is it. So what we have done is the documentation the way Chandra is on, right? Maybe this part, Chandra, I'm speaking for him. Or Chandra, step in please whenever you want. This is a very brief instruction, a summary instruction. So you can quickly glance through it for Airflow, for flight, and for Kubeflow. As you can see, the do part is simple. Just follow these steps and you will have a flight pipeline running. Right? But the detailed steps are here. In this case, what is a MLOps pipeline? There's again a sort of a review and so on and so forth. What features you expect? You're going to go through this more carefully next week. On Wednesday, I would strongly encourage you to at least read through some of this, right? So that you come a little bit more prepared next time. The tools, now which tool to use, and this table is really very good. Kubeflow pipelines, best for large-scale Kubernetes native ML workflows requiring strong integration with other ML tools and frameworks. Flight, it is ideal for complex, scalable, data-intensive workflows with a need for strong type safety and Kubernetes integration. Jenkins, suitable for teams already using Jenkins for CI/CD, looking to extend its use to MLOps with custom integration. Airflow, best for teams needing a flexible, general-purpose orchestration tool that can be extended to ML and other data flows. In particular, Airflow is very Pythonic. That's its distinguishing feature. Right? Of course, you can work without any of these frameworks. In fact, the first solution that you'll see will be without any of the frameworks. You will do data ingestion, feature extraction, train validation and splits, model training and validation, and model science. Remember, guys, we are in the first lesson, it is keeping it very simple. We are not going straight to fine-tuning a complex LLM model. But as they say, Rome wasn't conquered in a day, we'll do it slowly. Right. So this is all the steps. As you can see, the code is there. The same code, these functions, ingest data, will read from a file, pre-process data, train validation test. Chandra and team will carefully walk you through all of these. This particular thing, flight, for example, makes it very easy. Everything is just an annotation. Any function that you annotate with the task becomes a task. And a workflow is just a sequencing of tasks, right? This is what it is, right? You see this. Ingest, pre-process, test, train, and this gives you the flow diagram, essentially, of what is going on. So, and this language is fairly Pythonic and easy to grasp. It's a short learning curve. We'll take you through it and you will find that it's not hard. Docker, it's a very good idea to deploy these things because you're dealing with flight. It's Kubernetes. It will expect you to give it a Docker container, right? Or a Podman container. But here we'll stick with Docker. Right? So this question may come up, guys. Some of you will say, we use Podman. By all means, Podman is Docker compatible. And the same exercise you want to do with Podman, go ahead, do it. We will show it to you with Docker. Install this. Again, you realize that these are all very familiar steps. And this is exactly the workflow you will go through. Likewise for Kubeflow, you notice that for Kubeflow, nothing is different. It's almost the same. The syntax is a little bit more verbose, but it is pretty similar, right? One thing you don't get in Kubeflow is you don't get this beauty. You see that this is after its function calls. Like how do you chain the entire directed acyclic graph, the DAG? You use this syntax, whereas with Flight, you had the beauty of domain-specific language, which is just arrows, which looks, to me, it looks neat. It's really neat that you could specify the entire syntax with just these double arrows. So this is Kubeflow. Again, after a little while, it will look very familiar. And there are quite a few steps. Jenkins, very easy. These are the steps mentioned, but these images haven't come through, unfortunately, here. We will see what's going on. We'll fix this. Likewise for Airflow. We will clean up some of these notes. I think it's a bit of a mess here. When you download the project, you will notice that these markdowns are there for you. You can open those markdown files and check it out. So that is all I'll say, guys. It's going towards the end of it. I would like to summarize by saying, first of all, a very warm welcome to our MLOps, LLMOps, prompt ops, and God knows what other ops we will add to that list, course and workshop. It's a very fluid, fast evolving landscape. Trust me, by the time we finish this course, not only would you be very skilled, you would also realize that lots of new things have come up that we need to catch up on. Right? So we'll try to keep this course very fluid, keep incorporating new developments as they happen, but we want you to be, the outcome of this course has to be that you can take somebody's model, some data scientist's model, or AI researcher's model, and you can productionize it. You can take it through the entire flow, have proper data governance and management, model management, feature stores, pipelines, workflows, training on, let's say, RAID. You can do distributed training, distributed fine-tuning, distributed inference. You should, in other words, be capable of entering any company and being able to lead the MLOps project. If not lead, at least be very conversant and very productive on day one. That's the goal of this course. This course is a lot of work. It does not require a lot of prerequisites. If you feel that the Python looks intimidating, trust me, it's very simple. You'll pick it up in a day or two. We'll guide you through the process. We'll put tips on picking up Python. You will pick up. From a more practical note, at this moment, there are a few topics are really where the demand and supply curve is in your favor. In other words, there is overwhelming demand and very little legitimate supply. These 4 topics are MLOps, model fine-tuning, agentic reasoning, AI agents, and graph neural networks. You put any one of these on your resume and you have legitimate backing with a few projects. Trust me, by the time you have walked away from your computer, you'll start seeing emails coming to your LinkedIn box. So these are very hot topics at this particular moment. It's the right time to do all this. And again, this particular topic goes to the heart of the matter that most people know how to train a model. Very few people know how to take it to production. Very few houses have really succeeded. Development houses have really succeeded in taking production level AI systems. Just look around. How many AI apps are there that are running at scale? And that are also not running at scale, but managing to keep the cost down so that they are profitable. There are lots of apps that are running at a loss, right? But to run AI with a profit, keeping costs down, takes discipline, and it's also an art. Not everything is well known. It comes by doing. It's like tennis. The more you play, the better you get. With that, I would like to